All right, I'd like to get started, please. Okay, do you guys have questions on homework? So I asked Vikram this question, okay, do you guys have questions on homework? You know what he does? He yawns right in my face. Okay, I'm that boring, okay? All right, I get the point. I get the point. So no questions on homework then. Right? No questions on homework. Did you do your homework? If I do a chicken run, you will not be a chicken? Okay. All right. Does anybody, Ilham, you want to answer this question? Yes. Shh. You are learning to chat. Learning to learn. Learning to learn. What kind of math did you learn? No, let's be specific, okay? What do you think we've been doing in 2.3? Sorry? Okay, that's one thing, but you did factoring in algebra 0, so what's the big deal? Usman. Synthetic division, okay, that's something kind of new. You should have done that in algebra 2. Okay, yeah, no. Dividing polynomial. You know what? All these answers are right, but there's a grand theme to that. Why are we doing that? Why are we factoring? Why are we doing synthetic division? Why are we? Yeah. Thank you. Thank you. Thank you. Everybody get that? What was it? Zeros of polynomials specifically. Okay, is everybody all right on that? Right, so that's really the central theme of 2.3. So today we're going to do a really important theorem called the rational root theorem. Get this down and then we'll talk about it, okay? Yes? Okay, so you guys get the idea in the theorem, okay? What it's saying is that if there are rational zeros in a polynomial, notice that a polynomial like this, there are no rational zeros, because if you were to solve this, you get plus or minus root 2. That's not a rational zero. So we're not talking about that case, okay? We're talking about the case where if there are rational zeros, then the rational zeros will be of this form, where P is going to be factors of this guy, and Q are factors of this guy. Everybody understand what factors mean, right? Yeah? For example, 15 is factors 1, 3, 5, 15. Okay, is everybody okay on that? All right, let's see how this theorem really works and why it's so useful. Okay, why it's so useful. Okay, you guys are chatting too much. Okay, I can't really wait because you're holding all the other people on this side of the room. Okay. If you take a look at this example here, then the rational root theorem tells you that if there are rational roots, they'll be of the form P over Q plus or minus. You want factors of 1, which is just 1, over factors of 8. What are the factors of 8? 1, 2, 4, 8. Guys, go in sequence, okay? Otherwise, you're going to miss some out, okay? So it's 1, 2, 4, or 8. Which means that your zeros will be either 1, a half, a quarter, or 1/8, plus or minus. Okay? Does everybody see where these numbers are coming from? Yes? Anybody want me to explain that any further? You guys got this? Are you guys with me on this? Okay, now this is a quadratic that you've been solving since you are 6 years old. Right? Since before Gomes or Mission Elementary. Okay? How will you do that? How will you solve that? You guys are looking at me like blank. Today is sophomore day. It's not junior day. Yeah, if you're a sophomore on that, I don't expect answers from you. But if you're juniors, I do expect answers. Yeah, Kylie, how do you solve that? What the F? It's a quadratic. Duh! No, you factor it. Oh my God, Kylie, you get a brain fart. Okay, factor it. Do it. Do it. Yes, got it.
Is it -4x?
What the what? Factor it, dude. Factor it. Yeah. No, factor. Give me factors first. 4x minus. And now if you were to solve it, you'd get 1/4. Well, on these numbers, exactly what the rational root theorem is predicting. Okay? So I just gave you an example. There's obviously no way I can prove this theorem here, okay? All right, is everybody okay on this? Brandon? Trying to do a rave? Okay. All right, everybody get the rational root theorem? Okay, another example. Okay, so the rational root theorem tells you that if there are rational roots, then it will be one of these numbers in here. Okay, plus or minus 1, 1/2, 1/4, okay, 3, 3/2, 3/4, and so on. It's going to be one of those numbers. Now, let me just tell you that you don't want to do to start out with, you don't want to do synthetic division with plus or minus 1, because we're going to learn some other rules to see if plus or minus 1 work, okay? If they work, then we will need to do the synthetic division, but let's not start out with that. So I'm going to start out with plus 3. I don't know, it might work, it might not. I have no idea. Let's try it. So if I take a 3 here, bring this down, I get a 12, I get a 0, and then I get a 0, minus 1, minus 3, and my remainder is 12. So 3 doesn't work, does it? What should I expect here if 3 was a root? I would expect a 0 then. So that doesn't work. So we're going to start over again. Does someone want to try another guess? You want to try a minus 3? You want to try a 4? Okay, let's try a 4. Sorry? Yeah, why would you? I don't know. I'm doing it because Sona told me to do it. Haha. You can't try 4, right? Because it's not in this list here, Sona. It's not in that list. So you can't try 4. Are you with me on that? This list, really, the way you want to expand this list is it's going to be 1, 1/2, 1/4, a 3. You guys got it? Okay, so 4 is not in that list. So who's that, Kylie? You want to try what? You want to try 5. Oh my God. Oh man, you can see it's going to, you can already see it's not going to work. You're getting huge ass numbers in there. Okay. So, you know what, let's try a negative 3. Okay. So I get a 4. No, did we try negative 3? No, we tried a positive 3, right? So that's negative 12, that's negative 24. That's not going to work either. All right, well, we'll just have to keep on trying until something works. You want to try a half? Sorry? So now, what do you want to try? I told you not to do 1 because there are other rules we're going to learn how to do 1. Yes. 3/2? Who's that? Okay, Elizabeth, I trust you. Let's go 3/2. God, if you're wrong, I'll kill you. And I'm on record on this one. Okay, what do you get? Whoa! Oh my God! Woo! Can I give you a hug? Oh my God, that's awesome. Okay, so there will be some guessing on your part, okay? And you can complain, you can scream, but I don't hear things. I'm hard of hearing. Okay? So that means that one possible factor of this guy is going to be x plus 3 over 2 or minus 3 over 2. Nice, good job. And then the other part's going to be, hello, you guys, are you with me? Elim, pay attention here. Otherwise I'll move you right in the front here. 4x squared minus 6x. Nice. Okay, and remember you're trying to solve this being equal to 0. Are you going to do sim diff for this, Kylie? Are you going to do, you're not? Why not? No. Yes. I'm just catching you again because I want to make sure you know this is a quadratic. Right? Okay, can you guys go solve that? Anyone, question? Okay, guys, go solve this. Nate, solve it. Do it, man. God, you guys have no energy today. What's going to happen tomorrow? More energy, but distracted energy. Yes. Vikram. Yeah, you raising your hand? Oh, you're stretching. Elim, dare you solve this quadratic equation, Elim? You're thinking while you're doing your nails there? Got it, Dean? 2x minus 5 and x plus what? 2x plus 1? Oh, so you want to factor 2 out. So factor 2 out. 2x minus 5 squared. What are we doing here, man? Vikram, did you get it? Okay, you could have factored a 2 out there, but no big deal. 2x plus 2x minus 5 equals 0, so x equals negative 1, or x equals 5 over 2. Udara, what are you trying to do? Doing in a fashion kind of walking the runway here with Usman, trying to plan a runway? Okay, so you can see that the answers are 3 over 2, negative 1, and 5 over 2. And all these are rational numbers, and all of them are in this list here. They're all in that list. Are you guys with me on this? Ryan, Ray, I will move you right in the front here and chain you to the front desk. God, you guys got to focus, man. All right, does everybody get the rational root theorem? Sona, question. Everybody get the rational root theorem? Okay. Okay, then there's this other famous rule. So today it's all about tons of rules that you're going to learn how to solve polynomial equations. And I can say Valerie is totally thrilled by it. Valerie, what can I do? I got to teach you the stuff. Noah, why are you getting distracted there? Okay, so here's Descartes, famous mathematician. What other thing comes from him? Does anybody remember this? Yes. The Cartesian plane. Okay, the Cartesian plane. So get all the words down and then let's work on it, okay? Too complex, or 4, or 6, or 8. That's why it's an even number less, okay? An even number less. So copy this down and then I'll go over it. Okay, let's take a look at what Descartes is trying to tell you, okay? So remember, Descartes is talking about positive and negative roots. So in order to get the negative roots, you got to look at f of minus x. Okay? Did everybody see how f of minus x became what it is? Yes? Wherever you see x, In fx, you just put in minus x.